Yo, let's go ahead and talk about segments, congruent segments, and segment addition. So, one thing that I need to remind you is what really is a line. So remember, a line is just a line with two arrows on both ends, and then they extend to infinity, right? So there you have it. That's what a line is. So if I want a part of if I want to look at the line and I want to take part of that line, well, what do you have now? You have what we call a line segment. So one thing that I want you to take a look is this little sentence right here. It says, unlike a line segment can be measured because I'm taking a certain part of that particular line. This whole line here, I'm taking a part of this particular line because it has two endpoints, right? Here's an endpoint and here's an endpoint. Okay, let's go ahead and take a look at this particular, I don't know what you call it, a box or whatever. So it says a segment with endpoints A and B. How do I write that? What is the notation when you have a segment with endpoints A and B? Okay, so recall from the first lesson, 1-1, where you have a segment like this, A and B, and I look at the capital letters and I'm going to write them. I just write the capital letters, and what do I put above it? Well, I put the little line segment above it, and that's how you write the notation for this particular sentence right here, the statement right there. Okay, now a line that contains point A and B. Okay, so this is a little different. So we have a line segment over here. Now I need to draw a line. So a line looks like this, and it has to have at least two endpoints. Both has to have a capital letter. So I have AB, and then you write the little line, or draw the little line above it, and there you go. You have line AB, or you can write BA. Does not matter. It makes no difference, okay? And over here, you can actually call this BA as well, or line segment BA. So this is line segment BA, and then this is just line BA, okay? Now, the measure of line segment AB is written as AB. Okay, so why does this matter so much? Well, it's more about being formal. When I am just, talking about in general of a line segment, this is how we write it. But when I'm talking about the measure, that's when I'm dealing with adding or subtracting, etc. Okay, if I'm calculating, I write just AB without the line. So this is just AB without the line above it. And I'm only, when I'm talking about the measure of anything, that's when I'm just calculating. Okay? More details when you look through the notes, especially this video in particular, actually. Okay? So let's go ahead and talk about the distance and midpoint between 2 points on a number line. So, of course, you know what a number line is. It's just a line with some numbers on it, right? So if I want to find the distance, I'm like, okay, how far are you how far are you from me to you, right? That's the thing. I'm talking about the distance, the length between me, the how far are you, you know what I mean? I don't know how to say it, but here's the distance on the number line. How far away, there we go, is A then B? Or how far away is B then A? So looking at the distance on the number, we have a specific formula. It's basically the absolute value of x sub 1 minus x sub 2. Or you can say the absolute value of x sub 2 minus x sub 1. Absolute value is basically, when I'm saying the absolute value, that's the definition of that is how far away is the number from 0. Okay? So let's take a look at the midpoint of the segment. It says midpoint on a number line. If the coordinate of the endpoints of a segment are x sub 1 and x sub 2, then the coordinate of the midpoint of the segment is x sub 1 plus x sub 2 all over 2, or divided by 2. And that's just basically, you take those two numbers, you divide it by 2. It's just like you're trying to find the average of something, right? So that's what you can do there. So let's go ahead and take a look at this particular number line, and it says find BE. So I'm trying to find that measure BE. I'm calculating the distance between B and E. So let's find where BE is. BE is from here to, let's see, from here. Or I can just do from here to here. I'm just going to connect the dots. There you go. Well, when it says find BE, I'm trying to look for the distance between the two points. So I know my formula is the absolute value of x sub 1 minus x sub 2. And we know that x1, we can just say that x1 is -6 and x2 is 2. And I just plug it in. I have the absolute value of -6 minus 2. And -6 minus 2 is -8. If I take the absolute value of that, it just makes things positive. How far away are you between -8 and 0? How far is -8 from 0? 8, right? So the answer is 8, and that's your answer. And then let's go ahead and take a look at B. It says determine whether C and A and E and D are congruent. So when I'm saying congruent, I'm saying, okay, well, are the distance between CA and ED the same? Are they congruent? Are they the same? So let's go ahead and calculate C and A. I'm gonna go ahead and start erasing this. So C and A is right here. And I take the absolute value. So I have -7 minus -4. And we know that -7 minus -4, that's going to be, well, I see a negative times a negative, that's going to turn into a positive. So I have -7 plus 4. And then -7 plus 4, that's going to be -3. Okay? And so if I take the absolute value of that, that's just going to be 3. And what am I dealing with? This is for CA. So that's CA. For ED, well, ED is right here. So ED, and I'm going to write the absolute value of -2 minus 2. And that's going to be, if I do -2 minus 2, that's going to be -4. The absolute value of -4 is just 4, right? So that's that one in particular. That's for ED. So what can I say about ED and CA? Well, CA is 3, ED is 4. They are not the same. They are not the same number. Therefore, they are not congruent. So that is not congruent. Okay, let's take a look at C. It says determine the midpoint of DE, or line segment DE. Again, we're taking a look at the midpoint. Our midpoint formula is right here. I'm taking the average between the 2 points, the middle, right? So DE, again, is right here. So all I have to do is I use my formula, x sub 1 plus x sub 2 all over 2. X sub 1, I'm just going to say that's a -2, plus x sub 2, which is just 2. And then I divide that whole thing by 2, right? -2 plus 2 is 0 all over 2. That's just 0. The midpoint is 0. So here, if I draw that, here's -2, here's 2. The middle point between these 2 points here is 0. So that's 0. That's going to be my midpoint. Okay? It says find DF and the midpoint of segment DF. So what it means here is says find DF. I'm just trying to find the distance. Something that we've already done this with A and B, so let's do that with D. So DF, all I have to do is I take the absolute value. If I take a look, D and F are right here. I have the absolute value of -2 minus 5, and -2 minus 5, that's going to be -7. Therefore, if I take the absolute value, how far is -7 from 0? Well, it's just 7, so that's DF. In order for me to find the midpoint, I do x sub 1 plus x sub 2 all over 2. So I will write -2 plus 5 all over 2. And -2 plus 5, that's going to be 3. And then divide that by 2, it's just going to be 3/2. Or you can write 1.5. So these are your answers, 7 and 1.5. Okay? Next thing, it says between any 2 points on a line, there is a blank amount of points. So here, let's take a look at this particular line, and here are these 2 points, right? Between these 2 points, there's something between those particular points, right? Now remember, I said that a point is a location, and this right here, these two, or sorry, N and B, those points are just sticking out, they're popping out at you. But don't be fooled, there's actually more points. There's actually an infinite amount of points between these 2 particular points here. So what can we say? It says between any 2 points on a line, there is an infinite amount of points. In the figure, point blank is between points A and B, but point blank is not. Okay? So, taking a look at that, what point is between A and B? So here's A, here's B. What point is between A and B? Well, we can see that N is between those 2 points, but P is not. P is actually outside, and it has to be on the line. Has to be on the line. Yeah, so what I mean by that is when you have point P is between A and B, but it has to be on the line to be considered something like what N is, okay? Okay, moving on. So let's go ahead and move on to segment addition. If A, B, and C are collinear, then points B is between A and C if and only if A, B plus B, C is equal to A, C. Okay, so taking a look at this, what this is trying to say is that if I have a part plus a part, that's going to equal this whole thing, right? So imagine that you have a chocolate bar. Let's say you have a chocolate bar, it's broken into 2 pieces, right? So you have a part of the chocolate bar plus a part of another chocolate bar, or the same chocolate bar, actually. So a part of the chocolate bar plus a part of the same chocolate bar, that's going to give you this whole chocolate bar here, okay? And that's what it's saying. It's saying that if you have this part plus this part, it's going to give you this whole part here. So let's take a look at this particular figure over here. And it says, so segment addition posture allows us to say that AN plus NB, right? This is talking about the segment of AN and the segment of NB. If I add those together, what is that going to give me? This whole thing here, and that's going to be AB, right? And notice that I'm not putting the line here because notice that there's no line here because I'm adding or I'm calculating, therefore the line is just out of the picture, but it's still a segment, so just to let you know. And you can take a look over here. We don't write this. We only write that when no numbers are involved. Okay. So let's go ahead and practice drawing and setting up the equation for segment addition. So A says B is between A and C. So let's go ahead and draw A and C. And you're supposed to have those 2 points, 2 endpoints, because you're representing a segment, so A and C. And B is between these 2 particular points here. Well, I can just, boom, put B between those 2 points, and that's pretty much it. That's how you do it. Next thing, B, it says M is between H and K. It's the same idea. Here's H, here's K. H and K are my endpoints, and then M is between those 2 particular points. Now, it doesn't have to be in the middle. It just has to be between those 2 points, okay? So now that we have those 2 IDs, we can go ahead and transition to actually doing segment additions. So it says find the measurement of the following segments. Figures are not drawn to scale. So if I'm trying to look at this particular line and I'm trying to figure what FE is, so what's FE? Well, FE is this whole thing here, right? And remember, think about that chocolate bar example. I have 2 pieces of the same chocolate bar and they're broken in half. Or you can say, well, you have a part plus a part. If I glue them together, you're going to get that same chocolate bar back as it was when it was in its packaging. So we have this part here, which is 1.2. ED is 1.2. And this part over here, which is 1.9. DF is 1.9. And then I'm trying to figure out what EF. So I got to add those 2 things together, right? So I have ED plus DF, which is going to give me FE, or EF. It doesn't matter. The order doesn't matter in this case. So I have 1 plus 2 plus 1.9, and if I put that in my calculator, do the math in my head, that's going to give me 3.1. That's my answer. EF, or FE, is 3.1. Okay, this one for number 2, a little different. It has some variables involved. So again, part plus part is going to be the whole thing. So this right here is a part. This right here is also a part. And then this whole thing is the whole thing. 2x plus 5 is the whole segment here. So let's go ahead and just construct this. Let's set it up and then figure out what AC really is. Okay, so my part is x and my other part is plus 2x, right? I'm adding those 2 together. That's going to give me 2x plus 5. Okay, so if I combine the like terms on the left side, I see x plus 2x. That's going to give me 3x. And then nothing happens on the right side, so that's just going to be 2x plus 5. Now, I need to go ahead and solve for x. So subtract both sides by 2x. I get x is equal to 5. Okay, let's go ahead and read the directions once more. It says, find AC. What did we just find? Well, we only figured out what x is. We didn't figure out what AC is. So all I have to do is I'm going to go back, figure out where AC is. AC is this whole thing here, which is 2x plus 5. And notice that AC has this 2x plus 5, and I have this x here. Well, if x is equal to 5, then what do I do with this x? Well, I just take this, and I'm going to plug that in to that expression. So I have AC is equal to 2 times 5 plus 5, and then I just do the math. I have 2 times 5, which is 10, and then 10 plus 5 is 15. What does this mean? Well, AC is 15. Okay? And that's your answer. Lastly, it says find the value of x and rs if s is between r and t. So it has no picture. That means we have to construct it on our own. But we are already familiar with this because we've done a and b over here, right? All we got to do is we just read the directions and start putting things together. So here's r and t. Here's r, here's t, and we know that s is between r and t, right? So s is right here. So if rs is 2x, so this whole thing is 2x, and then st is 5x, the whole thing, r and t, is 32. Okay? So again, part plus part is going to give me this whole thing. Well, the part of that is just going to be 2x. If I look at it, this is my part here. My other part is 5x, so I'm going to add 5x. And my whole thing is just 32. Go ahead and start combining line terms. I have 2x plus 5x. That's going to be 7x equal to 32. Now I can go ahead and start dividing both sides by 7. And if I do that, that's going to give me... did I make a mistake? Yeah, I did make a mistake. This is supposed to be 5x plus 4. Well, let's go back. This is going to be 5x plus 4, which is equal to 32. So I'm left with 7x plus 4, which is equal to 32. And if I subtract both sides by 4, I get 7x is equal to 28. And then divide both sides by 7, I get x is equal to 4. So x is equal to 4. Again, I am looking for x, so therefore this is my answer. Okay, that's my answer. That's what x is. Now it says, what is rs? Well, I know that rs is 2 equals x, right? So if x is equal to 4 and rs is equal to 2x, what do I do with this x then? Well, I just plug it in with my 4. So rs is equal to 2x. And then I multiply that by 4, which is going to give me 8. Okay, and that's my answer. RS is equal to 8. So that you should have two different answers here. Okay, next thing. It says, if two figures have the same shape and same size, of course, they are congruent. I think you've heard about this maybe in 7th or 8th grade, right? If you have... let's say you have a triangle and a triangle, and they have it's the same shape, and of course they have the same size. You're going to obviously say it's congruent, right? So this side here and this side, that side of the triangle, they're congruent. This side and that side, right? Those are congruent. And lastly, this side and that side, they are congruent as well. Therefore, we can say that these are congruent. Now, if two segments have the same measure, we can also say that they are congruent. To take a look at this diagram over here, well, we can see that this line segment, this is 1.7, and this particular line segment, that's 1.7. Well, we can say that they have the same measurement, and if they have the same measurement, then they are congruent, and we also denote that, or we show the reader that they're congruent by using these little tick marks, and it's important that you understand what those tick marks are, because it's going to be important in the future. Okay. Those slashes on the diagram indicate that they are congruent. So there is a symbol for congruent, and it is this symbol. It is like a weird equal sign with the tilde on top of it. Therefore, we can say that line segment AB is congruent to CD. And why do I put the line segment now? Is because I'm talking about the form. I'm not calculating anything. I'm just being more formal. I'm trying to be like I don't know. You can say like I'm being general, right? If I'm not adding or subtracting anything, then I put the line segment symbol on top of it. Okay. Now, let's go ahead and try these other problems. It says Wx. Okay, so find Wx. What do I notice about this particular diagram or this picture? Well, I see that I have a part here and a part here and this whole thing over here. So that means I'm going to be doing segment addition, right? That part plus part is going to give me that whole thing. So, what can I say? Well, I know that this segment is congruent to this segment. Why? Because I can see the tick marks here, and I know there's just only one tick mark here, and these are two tick marks here. It's just a way to differentiate, say that this and this are not congruent. Okay, I mean this is congruent to this, but this is not congruent to that. But we know that these two things are congruent, so that's why we use two tick marks instead of one. So, okay, well, I don't even know the length or the measure of this one, neither do this one, but I know that they are congruent. So, if I don't know something, we usually denote that as x, that the unknown, right? So, x and x represents these unknown segments, and I know that x is part of this whole thing here, and this other x is this part of this whole thing here as well. So, if I add them together, that's going to be 2x, but hold up. X plus x is equal to whatever's on the right side. That's going to be 6. Right? X plus x is equal to 6. That, if I combine like terms, I get 2x is equal to 6. And if I divide both sides by 2, I get x is equal to 3. Okay? Now, trying to figure out what wx is. Well, I know that wx is 3. Because wx originally was just x. If I plug this in, I get 3. Right? And we can confirm that, well, 3 plus, well, this thing is also 3. That's going to give me 6. So the answer is 3. Last problem, it says determine whether the pair of segments is congruent. Okay, so looking at line segment MN and RQ, are these congruent? Are these congruent? Are these congruent? Well, we know that MN is 4x, and we know that RQ is also 4x just by looking at this. Here's MN and here's RQ. Are these congruent? Well, here's 4x and here's 4x. Of course, they are congruent. Whatever I plug in, it doesn't matter if x is 2, 1.1, 5, or 7, because you're going to get the same result every time. So we can definitely say that these two are indeed congruent.